Hello everyone, video 1 of module 3. In module 3 we mainly discuss about the different boundary conditions and how to design model the foundation and model the soil stiffness for retaining walls and foundation and piles. And in video 1 we mainly focusing on very simple rigid base building, and then gradually we add other details and I show you how to actually define the boundary conditions. To save the time, I created a very simple four-story building, one level basement. And you can see here Z is -3, which is the base level, and then upper levels we have just simply a grid of beams and columns with a lift core wall and one shear wall here, just to give you different type of elements to enable me to show you how you can actually prepare the boundary conditions for these type of elements. So all beams are 300 by 450 concrete, all columns are 400 by 400, and a slab is 200 RC, and lift walls are 200 as well. If you want to see the sections, we can come to display option and activate sections for frame and sections for area. And if I press apply and I zoom in here, you can see concrete beam 300 by 450, 32 MPa, 200 slab, 32 MPa. And if I go to the elevation, you can see the columns are 400 by 400, 40 MPa, and this is a 200 wall, 40 MPa. And if I move to reach to the middle of building, which is here, you can see the blue mark here to show which grid I am. So here the concrete walls are 200, core wall 40 MPa. And if I keep going, you can see the other shear wall that I set here, that the name is the same, 200 wall 40 MPa. So this is generally the model I created. I didn't set any support, any boundary condition, because I want to do it in this video and to show you how to do this. So the first thing is, if you don't want to model any foundation, you just need to define the support for columns and for walls. To do that, we can get back to plan and move down to Z-3. We can select all of them. Here is really back to the condition you have. If the columns are in a big mat and they are moment resisting, you need to define them as moment resisting. If we have small pad footings, generally they are not very moment resisting, so they need to be pin connection. So I assume here that in this model we have actually moment resisting columns, but for walls is just a pin connection. So what I will do, I just need to locate the walls. So the walls are between grid C and D and also grid F. So I will move back here. I will remove these grid lines. Those are for walls. And then the rest of the actually grids and points are for columns. You see, even I extended columns down to the basement. It's really back to the structural system. It could be just the wall here and columns end up here. If the wall is strong enough, there's no problem with that. And really back to the base actually level you have, that I will explain shortly after setting these supports. So I'm coming here and I assign support, or I can come to assign, joint, and restraint. And here I said I want to go for moment resisting connection. I click on this, so all rotations and translations are restrained, and I apply this. For the walls, what I suggest is don't just accept that wall is one big span and you have just 4 points, because it doesn't transfer loads down to the foundation properly. If you just are modeling the structure and you don't want to design the foundation at this specific stage, that's perfectly fine. You can simply just put the support for wall and then it's finished. If you want to design the wall or want to transfer these loads, for example, to safe model, my suggestion is you need to divide the frame and make it actually in a smaller pieces and more accurate in terms of transferring load. So to do this, I will back to the model I have, and what I do generally, I mesh them or divide them vertically. It doesn't have to be divided horizontally because it doesn't do anything for us. We just need some vertical actually segments here. To make it more clear, I will go to elevation, then I just go to general option and back to the standard. I also remove our sections, everything, so it would be more clear for you. Then what I need to see is what is axis 1 and where is axis 1, where is axis 2. So I'm coming to area and update local axis. So local axis shows me which one is axis 1 and axis 2. So what I need to do, I want to subdivide this shell to vertical elements. That means along point 1 and 2 I need to subdivide them, and along point 2 and 3 I don't need to subdivide them. So to select all elements, I can come here and select sections. So I'm coming to select properties and coming to area sections, and here I will select 200 wall. I press Ctrl key and I can select 200 core wall and press select. So if I move here, you can see that core walls are selected as well, and other concrete walls which are in green color. Now I want to subdivide it, so I'm coming here and I said okay, from grid 1 point from point 1 to 2 I want to have them at 1 meter maximum mesh, and 1 to 3 I don't need. So the height is different between 3 to 4. I just be conservative, I can put it 5. And when I press apply, you can see that all walls are mesh or divided vertically. Yes. Now I have a better connection with ground. So what I'm coming here, I need to select all joints here. That is including all joints here. So you can exclude the joints of columns if you want, or you can add them all together. Because columns are confined at the basement, you don't have too much moment, but it's really up to you. You can come here and again by clicking on columns one by one you can deselect them. So every click is select, the next click is deselect, so that's automatically here. You don't need to choose deselect option. So we deselecting the columns and just keeping the walls in this group, and here a few more. Yes, so it's done. Now I have wall here as well. Now I come to restrain and I choose just pin connection and I apply. So if I go to 3D option here, you can, so to see that here, okay, let me explain you something is important. When you apply any command, that active page automatically show the pin connection. But what you, if you come to this menu, for example for joint, you see that the restraint is not activated. So if you unclick here and put apply, nothing will happen here. But if you activate this page and apply, you can see the restraint coming. If you remove it, restraints will go, but here not. The reason is it's preview of the model based on the command you apply. If you don't want to see the restraint for this page, is not happening by clicking or unclicking restraint like this. What you need to do, you need to click on deform shape. So this is applicable for all details, everything you apply. If you change the section, if you want to see the displacement or anything like that, you just need to back to undeformed shape. So let's back to here again and show the restraints. So you can see the restraints here, and you can see the restraints of the columns are moment resisting, the restraints of the walls are pin connection. So I set the restraints of the wall. What else I need to provide? I need to figure out what is my base level. Is the basement completely confined, or is the basement actually free and there is a gap between the excavation and the wall? So that will also define your base level in earthquake. To just make it more clear, I have a snapshot here to show the type of basement we have. If basement is fully confined like this, you actually have lateral support at the soil level. It doesn't have to be exactly rigid support because soil has a stiffness, depends on type of the soil. If it's rock, probably, but if it's sand or clay or just a field, uncontrolled field, you don't have that much lateral stiffness. If the excavation is wider than the basement, then actually the building is free and the base level is at the lowest basement level. If it's like that and is completely confined, your base level in earthquake is here. For these two, you can see the base level is the same here. Here, because one side is confined, one side not, based on typical seismic provisions, your base level is the lowest free, actually laterally free level, which is here now. In our case, the basement is fully confined by soil around. The quality of soil is just medium dense sand. So we need to define the spring stiffness and put the spring support for the wall. So how we can do that? We need to define a spring for shell elements around the building. Few things we need to pay attention. When we selecting elements for applying a spring, we need to ensure that which surface of the shell we are applying. So if I come closer, you can see that here grid axis 3 is outward, but here axis 3 is inward. And I will explain you why it's important, but I want all walls, retaining walls, have axis 3 outward, not inward. So I can see in this corner I need to change this group of wall, and then if I back to original condition and come to here, you can see this is inward and this is inward. And again, when I'm coming here, you can see these two are outward. So these two are okay, but I need to update these two elevations. So that means grid 1 and grid G. So I'm coming to YZ axis, I'm in grid F, so I'm moving forward, coming to grid G. Just bear in mind that your view is from one side for all walls. So if I become closer, what you can see is this is a right hand rule. So you actually looking from this angle, so looking from outside of this wall. So when you see, if you check your right hand rule, you see the axis 3 is inside the building, but don't be confused. Sometimes people feel that they are looking from inside the building, not necessarily. You're looking from one side always. So in that case, you're looking from outside of the building. So the best way to exactly figure out which face is out face, you need to view the 3D model. So if I come here and select all those shell element, doesn't matter if I'm selecting frame element. Then I need to come here to assign and go to area and reverse local tree and apply. If I do that, then if I zoom here, now you can see this is outward. The other side I need to do is this. Before I move, what I can do, I can select all shell elements here, and then I can come and deselect frame elements. So coming by deselect properties, frame sections, and I deselect columns and beams just to ensure I'm not choosing any of them. Deselect, and then I create a group for myself. I can see here what's been selected, so just areas are selected now. So I can come here and go to assign to group, and then I can create a group for myself. So I'm defining a new group and mention this group is basement wall, and I press OK and OK, and here currently I put replace, but if I add anything later I need to put add to the group. So I put apply. So now these elements are in basement wall group. So if I right click in any of them and I come here to assignments, and you can see here if I come to group, this is the basement wall group is here. Okay, so it's selected. Just to ease of select, I will come to display option and I'll mention that frames not in view and apply. So in that case I have just the wall, so I don't need to have this issue about selecting. So let's move to the other side. I can move the other way, which is easier. So I'm coming here, I select all those walls, and I'm coming here, assign to group, and then I have this one. I must be very careful, I need to add to the group. If I replace, the previous element will be removed from the group, so I apply. Then this is YZ plane, I'm going to XZ plane, and first of all I need to see which plane I'm looking at. So currently I am in this plane, so this plane is the one that I need to change. So I'm coming here, select all of them, I'm coming to assign, area, and reverse local axis, apply, and you can see now the axis is outward, sorry. Now you can see the axis is outward. Now I'll select them again and go to 3D. So I'm in the last, actually the first grid. So if I move one backward, I can select the other side as well. I select them all, and again coming assign to group, and I add them to the group of the basement wall. Add to the group, apply. So now all retaining walls are actually with 3 axis 3 outward. You can see here, and this is the other corner. So all of them are outward, and all of them are selected into the group of the basement wall. So I can come here, select by group, and select basement wall, and you can see all walls around are selected. Now I want to define a spring stiffness and assign it to these walls. So I'm coming to assign area, I'm coming to area spring. I need to define the stiffness of the type of soil we have. Is it medium dense sand, so lateral stiffness is something around 9,000 kilonewton meter per square meter. I have different types for a spring, could be tension and compression, could be compression only or tension only. If you want to choose any of them, you need to run nonlinear analysis, which is not in the scope of this training. So we cannot choose them. Actually, the soil is always compression only because soil cannot take any tension. But how we can use linear analysis and make the boundary conditions accurate enough for our job. So we choose tension and compression. I should apply either our top or bottom face or edge. So if I want to go for top means outward of grid 3, axis 3. That's why I try to make all of them the same. So for all of them are top. Now, where is the spring tension direction? If you want to move this building in and if you have a spring out, actually the tension side of the spring is outward. So we need to change this one to outward. I hope it's clear what I said. So if you have a tension spring on out face of the shell and you want to move shell inward, actually this spring will be under tension. So the tension would be outward because it wants to keep the shell at the location. If you move the shell out, then that compression would be inward. So I'm choosing a spring local top and the tension direction outward. Now we need to do one thing more. As I said, we want to choose tension and compression type of spring. The reason could be just because of ease of analysis, or we don't have advanced license with nonlinear analysis. How we can make it right? What's the behavior of the soil here? If you have any load, for example, lateral load on the building along a positive y-axis, what will happen to the basement? This side of basement is fully under compression by soil. This side there is no resistance because soil is under tension. And if you have load in the opposite direction, a negative x-axis, what will happen? This side is fully under compression. This side you have no resistance because there is no tension on soil. That means always you have one side fully under actually resistance. So how we can simulate this? Because tension and compression would work in both sides. So if you apply load here, when you have tension and compression type of spring, one side is under tension, the other side is under compression, and both of them have the stiffness of 9,000 kilonewton per square meter. To simulate this, we simply make this one half. In that case, we have the same lateral stiffness of the soil in the real actually behavior. So what else we need to do is we have options here in terms of, we can add to existing spring. If you want to add any different spring later, you can add, you can replace it, or you can delete the existing spring. Currently, we keep it at replace and we press apply. So this is how we can set the spring stiffness. If I come here and right click on any of them and I have a look at the joint spring, I can see the spring is 4,500, tension and compression, normal to the face, top and outward. So all information of area spring can be seen here. So this when you do right click, you can go to any element information, area or frame or joint, or later solid when you learn how to use solid. So this is very useful, and you can see if you applied the specifications and different stiffness or properties correctly or not. So this is video 1 of module 3. We simply just define lateral stiffness for the retaining wall, and we use simple actually just rigid or pin connection for the columns. In next video, I will show you how to define the foundation and how to create model for pad footings and how to apply a spring stiffness for foundation.